Instead of writing sampling type, mixing type, I'm using input output. So input side, mixing will take place and I will use series or shunt mixing. Output side sampling type, instead of writing voltage or current, I'll be using series and shunt. How to remember that? Voltage will be same in parallel. So wherever you have, instead of writing voltage, I can write it as shunt. Current will be same in series. So instead of writing current, I'll be using the term series. So it is of the format input output combination. So input side mixing can be series or shunt. Output side sampling can be series or shunt. So the four combinations are series, shunt, series, shunt series, shunt. That is the four naming. Is it clear? So it is same as notation one, only one change I am going to do. In the sampling network, instead of writing voltage or current, I'll be using the term series or shunt. That also you cannot randomly use because voltage is same in parallel. So for voltage, I can use only shunt. And current is same in series. So for current, we can use only series. So four possibilities, four types of feedback amplifiers. How to relate both? See here. Assume if you know the first name, voltage series feedback. What the second name? This series, write as it is. And where voltage will be same in shunt. So it is going to be series shunt feedback. See the first name? Voltage series feedback is the name in notation 1. In notation 2, it is series shunt feedback. Here second one, you see current series feedback. Write this series as it is. When will current be same? Current will be same in series. So it is going to be series feedback. Is it clear? You should know how to write one notation from another notation. You should know how to convert from notation 1 to 2 and from notation 2 to 1. Both should be thorough. For that, you should have a clear understanding of the notation 1 and notation 2 independently. Notation 1, you see current shunt feedback. So write this shunt as it is. When will current be same? Current will be same in series. So it is going to be shunt series feedback. Last one, voltage shunt feedback. Write the shunt as it is. When will voltage be same? Voltage will be same in parallel. Parallel is also called by another name called as shunt. So it is shunt feedback. So this is notation. We have seen how to convert from notation 1 to notation 2. Any doubt so far? Anybody is having confusion or queries in the two types of notation, how to convert from one to another? I have told you all the shortcuts. Any queries you can ask now. This is very, very important to understand the feedback amplifiers. Any basic questions, please put up. Don't hesitate to ask. Anybody wants me to repeat the notation and conversion, I can do it. Otherwise, I'll go to the next topic. And yesterday we have seen the effect of negative feedback on input and output resistance, right? We can clearly say from this easily what will happen to input and output impedance. See here in the second notation, input side I have series. So in series, resistance will increase. So when I have this series shunt feedback at the input side, my resistance will be high, and shunt is at the output side. So when you do parallel combination, the resistance value will decrease. So output resistance will decrease. So in series shunt feedback, input resistance will increase, output resistance will decrease. Next one, series feedback, you see, since I have series at the input side, the input resistance will increase. Since I have series at the output side, the output resistance will also increase. Third term, shunt series feedback. Since I have shunt at the input side, the input resistance will decrease. Since I have series at the output side, output resistance will increase. And the last one, shunt feedback, you see, since I have shunt at the input and shunt at the output side, both the resistances at the input and output resistance will decrease. So you can see four combinations for input and output resistance. Both are decreasing, both are increasing. Input is increasing, output is decreasing. Input is decreasing, output is increasing. So you can say the input and output resistance values just from the notation of the amplifier. We have studied theory regarding this yesterday. That if we without theory, if you want to say it easily from the name of the feedback amplifier, you can do so. So from this, you can clearly say what will happen to the input side and output side of your amplifier. Accordingly, you can say whether it is going to be increasing or decreasing. Remember, series means the resistance will increase, shunt means the resistance will decrease. So depending on series is present in input or output, that particular side resistance will increase. Depending on shunt is present in input or output, that particular side resistance will decrease. It is going to be very, very clear logic.